So welcome again, everyone, to the symposium. And let's check the Q&A if there is anything. I don't have the sound. It's okay. Okay, so it was an old one. Yeah, so let's really start now. Good. And first, I was welcoming our 4 speakers. So thanks for being with us today. I know it's a very busy period of the year, so I really appreciate that you made it to Lausanne. And also, as you have seen, the workshop will be streamed on Zoom and YouTube, and also be aware that we will take a few pictures for the social media. Okay, before starting with the topics, let me spend a few words for our sponsor, which is the NCCR Automation. So NCCR Automation, it's really a project quite a big size. NCCR stands for National Center of Competency in Research, and this is probably the largest size of projects that we have in Switzerland. So the Swiss government, from time to time, funds networks for doing research which is of interest for the Swiss community and economy. And that's really a center. So it's more than a project. Research is at the core of the project, but then we also have other areas that we cover, like KTT, promotion of young scientists and gender equality, and also links with the international community. For the research, we do have 2 main clusters. One is devoted to methods, and the other to applications. And in terms of methods, we develop new algorithms, hopefully, in control, machine learning there. And also, we have a work package devoted to computational methods, which means optimization, embedded systems, and also cybersecurity. And then we test the methods into different application domains, like those that you see here in the slide. For the first part of the NCCR, the main focus is on energy systems, but then we also a number of activities into smart mobility and Industry 4.0. And in terms of people, well, it's a very large network in Switzerland. So the leading house is ETH, and the majority of the PIs comes from ETH, including the director, John Ligeros, and the co-director, Gabriela Hug, which is with us, I believe. Yeah, it's that. And besides ETH, we also have other 3 institutions that are participating into the project: EPFL, EMPA, which is a research lab, and the University of Applied Sciences in Dubbeldorf here. It's not just the 19 PIs. We also have 10 affiliated members that help us in with the research that we want to do, and very importantly, our students, PhD and postdoc affiliated to the NCCR. And last slide, it's about the management. Okay, for such a big project, you need a substantial management. And therefore, we have our general manager, Elisa, here, which is sitting with us, is in the back of the room there. And then Frederick, which is a scientific officer. Communication is supervised by Arian and Linda, and Benjamin is taking care of KTT. And the core team also is helped by Saverio and Silvia for the science part and equal opportunities. Okay, so let me go back to the symposium. Probably I'll skip a few slides to be on time. As you know, the topic of the symposium is neural networks and control. And of course, I think you are all aware of the fantastic applications we have seen in the last years. Personally, I've been very much intrigued into the area, starting from the research of DeepMind. So there has been a very influential paper in 2013 about learning how to play Atari games from pixel. And then the AI system has evolved for playing StarCraft, but also for beating champions in the Go game. This was in the news a few years ago. And also research has evolved out of the virtual world to come to the real world. So now we have also application to robotics, automated driving, green buildings, and many other sectors. Good. So it seems that really the convergence of dynamic system, neural network, and control is happening. My question is it a new and exciting field? So exciting, yes, but new, probably no. And here I'm taking a dive back into the past in the 90s. And I took from my archive this paper, was a survey in Automatica in 1992, talking about neural networks for control systems. And that's enough to read, I think, the first sentence of the introduction in order to realize that there was a lot of excitement about the area. So the first sentence is, no one active in the field of control systems can be unaware of the growth of papers, journals, conferences, and conference sessions devoted to the topic of artificial intelligence. So a strong sentence. And actually, at that time, there were several reasons for being interested in neural networks and control. First, in terms of features, because neural network naturally provide models of nonlinear multivariable systems. And this is another quote from the paper telling you how important this field was perceived for nonlinear control. Also, a lot of researchers were fascinated by universal approximation theorems that roughly means that you can approximate a continuous function arbitrarily well if you take a big enough neural network. That's a very loose statement. And finally, algorithms like backpropagation were already there. Backpropagation has been invented in 1974, so even before the date of the paper. And what about the relation with control? So that's another figure that I've taken from that paper, right? Where you see topics in control and topics in neural network, and there are strong parallels. So let me just highlight a few analogies. It was very well understood how adaptive control and supervised learning have some similarities in common, but also how much neural networks can contribute to nonlinear system identification and plant inversion, which is a building block for designing controllers. And last, also, current networks were already there, and the link with feedback system theory was already in place. Okay. Now, what about the research topics in 1992? Well, if you read the slide here, you see topics that resonate pretty much with the research that we are doing today. For control, people were interested in certifying closed-loop stability and robustness, but also how to design suitable neural network architecture for control, right? And in nonlinear system identification, the key topics were how to guarantee persistence of excitation for training a neural network and how to make it converge to the true model, and also to study identifiability and generalization capability of neural networks. Okay, so these are pretty much problems that we still have today open in the community. So the next question is the following: was neural network control a big success? So there was a lot of enthusiasm for neural network control, but the point is that well, probably not immediately. So that's a timeline, and here you see the date of the paper I was mentioning. And on the y-axis, you have the number of publication on neural networks in Automatica and transaction automatic control, right? And you see that there is this period where the number of publications was pretty much stagnating, right? So there was not an exponential explosion as one would have imagined. Why? Well, several reasons. Probably one is the correlation with the so-called neural winter. In the AI history, there have been two historical winters where the interest in the area went down a bit. First was in the 70s, and the second it's here, pretty much in the same years that are in this band in control. Okay. But then the point is why we should be interested now in the domain, because there were a lot of things that were missing. And first, sorry, here it's I'm getting more and more. Okay, cannot go back anyway. A lot of things that were missing. First, computational resources. Okay, and computational resources, well, it's enough to look at this diagram where I have the timeline here on the horizontal axis, and the number of petaflops which are needed for training an AI system. And in 1992, we were there, right? The top of the state of the art in AI was a reinforcement learning algorithm for playing backgammon. And now the training time it takes for training this AI system, it's about 10 seconds now on your phone. Okay. But computation is not everything. We also the state of the art in optimization was very different. Think about that methods like accelerated gradient or as stochastic gradient methods, they are much more recent. They happened at the beginning of this century. And not to mention software frameworks like TensorFlow and PyTorch, which are very recent compared to the paper that I was showing. And finally, also in control, the situation was very different. Lots of tools that we have now were not available at that time. For instance, input-to-state stability was about to begin in the 90s. Hybrid systems were not there at all. Contraction theory has been probably initiated by a seminal paper by Jean-Jacques Slotin here in 1998. And other topics like monitoring control system, consensus and synchronization were not, again, within let's say, the focus of control. So a lot of new drivers for research are available now, and then which are the open challenges. That's one of the topic of today's symposium. So let me here just raise 3 questions which are related to the presentations that we will see after. First question, how to guarantee rigorously stability and safety when using neural network for control and reinforcement learning. Second is a bit provocative, but the point is, do we only need computation and optimization in order to make progress in this area, or we need different sources of inspiration in order to make progress? And third, well, now there's this idea of doing a control of a system over the entire lifetime, right? So how it's possible to deal with systems that are evolving continuously and environments that are also evolving continuously, okay? And probably for our students, the biggest question is, what's the future of neural network control? Is it bright, or there are reasons for which we can already say there will be another winter ahead of us? And but of course, I'm not providing the answers. This would be for our speakers. Okay, just a couple of final slides. I guess I'm almost on time. Yes, just a bit late. That's the program of the day. First part of the day, we have 2 talks by Jean-Jacques Slotin and Zico Coulter. Then we'll have a coffee break. And second part, we will have Davide and Chuchu that will deliver 2 talks. And then we will have a final panel discussion of 1 hour where we can ask any question we want to our speakers. And least but not last, an apéro concluding the day. Just a couple of more slides. One is for thanking the organizing team, especially Linda, Elise, and Frederick from the NCCR Automation, Nicole from our lab, and also I would like to thank the coming chairs of the sessions, Alberto and Georgios, for the 2 parts of the workshop. And don't forget that tomorrow we will have another workshop, so that's not the end of the story. The workshop will be here in the same room, on a slightly different theme. We talk about the socially responsible automation, and these are our 4 speakers. Unfortunately, Emilio couldn't come, so Andrea will kindly replace Emilio. And that's everything. So thanks a lot for your attention.